After the Columbia accident and the decision to retire the shuttle, that had a significant impact on the International Space Station budget. What was our plan before, and now what will our new plan have to be? And it had significant budgetary impact. So our plan before, we had a budget profile looking out over the years. And we were aggressively working to bring that profile down. As we completed the assembly of ISS and we understood it better, we would be able to maintain it and sustain it at lower and lower cost every year. At least that was our plan. And our idea was when there's literally thousands of parts that could wear out or fail on board the ISS. Our plan was to actually bring them home, repair them, fly them back. So we had a relatively few number of spares sitting on the ground because it was just a matter of time before we could get it home on a shuttle, repair it, fly it back up on the next shuttle, and we're good. When we decided to retire the shuttle, now all of a sudden we have to go build some of these spares. So we actually have to go re-enter in manufacturing in a number of very expensive devices. And the issues there were, one, the production lines shut down, and so the companies have moved on. The people who built them and the machines and all the instructions and the test equipment, all those things had to be resurrected. And then there's obsolescence. So the part that you used, in particular electronic parts, the electronic parts that you used 5 years ago, don't exist today. They've moved on and have better parts, but they're different. So you have to change the design of these devices that we're going to use on ISS. So we had significant costs to go restart production lines, so we had to factor that into our budget. In addition, when a device failed, we would throw it away. In the future, we were throwing it away rather than bringing it home. So now, on a cost savings point, we get to close down the depots on the ground, the guys who are ready to go repair our devices. So we no longer had to incur that cost. And then probably the singularly largest cost was now to launch cargo up to the International Space Station. We decided to go with commercial companies to go fly our cargo to the ISS. A shuttle flight could carry, say, 30,000 pounds up to ISS. Of that, in terms of useful cargo, was less than that, probably in the neighborhood of 12 to 15,000 pounds of useful cargo. But it cost $500 million to go fly a shuttle. We were looking for a significant change in the cost per pound of cargo to ISS, so we opened up a commercial contract, and I asked any company that would like to go bid on this. We ultimately selected two companies, SpaceX and Orbital Sciences, to go fly cargo to the International Space Station, and we are now in the process of those guys actually flying cargo to and from ISS. So that was a significant change in our budget. In the space station budget, we actually didn't carry any cost for transportation. That was all carried in the shuttle program. Now all of a sudden we had a significant increase to our budget to cover the cost to these commercial companies to fly our cargo. And finally, our plan previous to the retirement of the shuttle was to fly crew members to and from the space station, to rotate them on board the space shuttle. Now, of course, we can't do that. So in the interim, our plan was to fly them on Soyuz, and we have to actually procure those Soyuz seats from the Russians until NASA or the United States created another launch system where we could fly humans to low Earth orbit. And we're in the throes of that. Now we're looking for the same type of commercial approach, entering with commercial companies to fly crew members to and from ISS. In the meantime, we have to continue to buy those seats from literally the only other place in the world to fly humans to our space station is in Russia. So we enter in negotiations periodically to go buy seats for the next year or two. And as our commercial companies are getting ready to go fly humans, we'll go marry those up so that we continually have the ability to fly our crew members to ISS. Again, that's a significant upper to our budget. Previously, the cost of flying humans from low Earth orbit was in the shuttle. Now it's on ISS. So while we were, prior to the announcement of the retirement of the shuttle, we were aggressively working to reduce our budget. Now all of a sudden, we went from a $2 billion program to a $4 billion program. So significant impact for us to manage. So some of the lessons that we learned in that budget era and our drastic changes to our budget. One is when you're a program and you're used to procurement of in our case, $2 billion, and now you're jumping to $4 billion. That's a huge surge in the system. And so how do you grow very quickly to go do that? So we had to, you can't just go hire, double the number of people working. That doesn't work. You have to ease them into the system. And so that's one thing we had to go work through. Really think through, how do you grow from our size to another size? How do you be as efficient? So instead of growing 100%, we tried to grow 25%, and we grew a little bit, see if that was enough, and then we would grow more. So that was a big deal to us. The bigger lessons though were in how do we capture all the knowledge when we're building up our devices. How do we manage the obsolescence of it, and then ultimately, how do we manage the decision to keep a depot on the ground, or to have this philosophy where we'll throw things away? And so today we have a much more aggressive obsolescence program. Every we call them ORU, orbital replacement unit. We actually continually look with all the suppliers and all the piece parts in those ORUs and say, hey, this one's now going to be obsolete. Should we go buy some of those parts before they disappear from the store shelves? Or should we just let it go and we know we'll redesign this ORU at some point in the future? So we have a very aggressive obsolescence program today. And I think that's really important for a long duration program, is up front you have to know to look for those obsolescence, because if something changes in the future and you have to build more or repair more often than you anticipated, you have to have those parts in your hand, or incur sometimes a very significant build to go do the engineering to modify or even redesign completely that particular ORU. The other thing was, how do you go through and make sure you capture all the special test equipment, all the test procedures, even all the factory notes to go build up some more ORUs. And so in the beginning we thought, well, we're going to build a few of these and we're done. We'll take all the equipment and the documentation and we'll go put it in a warehouse, but we're never going to use it again. We're just doing that just to be safe. And then, of course, that wasn't the case. We actually pulled a lot of that back out. Frankly, today we're even pulling some of it out and reusing it. So in a long duration program, it's very, very important that you take the time and spend the resource to put that equipment away, and that you maintain it if it requires maintaining, and that you actually capture the documentation so that you can bring those things back out of stores if you need them. Or you expend a tremendous number of resources to go recreate it, to go really understand how it is to go assemble one of these devices. And so that was a big lesson for us. And so we're much better today about transferring that factory equipment and what do we do, and have a very good plan, I believe, about how we consolidate that and store it and maintain it over time. And of course, you look for efficiencies too as you go. So those are the big drivers for us as a result of this. And as a result of this decision, they were really budget driven. We knew we had to increase our budget, but we didn't want to just automatically double everything. We want to do it as efficiently as we could.